Welcome to lecture 50. This is also a hands-on exercise, rice yield simulation for varying inputs, particularly weather and water management. If you see previous lecture for hands-on exercise, we discussed about the rice yield simulations for varying soil type and nutrient management. So, we have shown you how to go for the enter create the treatment window, the treatment file or treatment screen. If you see how to create make your treatment entry there for the different soil type and different nutrient management. So, also you have seen the response of the grain yield to different soil and the different nutrient, how the grain response to nutrient management vary as the soil type varies. So, that we have discussed in the previous lecture. This lecture we will be discussing about the two inputs, similarly the weather inputs and the water management. Rice, rice is grown under the the fully available water conditions. This is grown usually under saturated conditions where there is no water stress. And many cases we keep the rice field under flooding conditions. The rice does not require flooding. Saturation water that can give the good yield. Flooding does not make any way for the improvement in the grain yield. Saturation, you can save lot of water, you can get a good grain yield. So, here we have we do some one exercise where the water management, either you can go for the rain fed conditions or you can irrigate. So, how the yield differs for the rain fed conditions or you can give for irrigations, and also how the yield responds to weather. So, we are not going to give the different years of as a weather. The same year, if you choose the planting date in different dates, then the crop experience different weather. So, we will have the two planting dates. One planting date as a normal planting, what is recommended for the farmers for the eastern India conditions. So, eastern India rice is grown mostly under rain fed conditions, because we get the rainfall here 150 centimeter, that is 15 millimeter rainfall, and of which around 80% 120 centimeter rainfalls received during the monsoon season, that is June to September 15, we get around 80% rainfall, that is 1200 millimeter, and rest 300 millimeter is spread all over the seasons. So, rice is grown during the monsoon season, and that is a 1200 rainfall receives during the monsoon season, that is enough for the growth of the crop and to get a good productions. So, we will see if you go for the changing planting, how in the under the rain fed conditions, how the weather, because of the non available rainfalls, if you go for the late planting or early planting and normal planting, how the rainfall pattern influence the crop production, the yield of the crop, that will be explaining in this lecture. So, this exercise here, this comes exercise 2. Here you can see the simulate the rice grain yield for the N application level 200 kg per hectare. We have kept the single dose of fertilizer, because here you do not have the treatment for the different nutrient management. So, we have kept the constant dose at 200 kg nitrogen per hectare. Application method is same as the question 1 what we are given in sandy. So, the soil you are looking for the sandy loam soil. We take the sandy loam soil for these conditions as Kharagpur conditions, eastern India. We have sandy loam soils. We take sandy loam soil, the nitrogen fertilizer 200 kg per hectare under two conditions as water management, you can say rain fed as well as irrigated conditions. We go for the rain fed simulation for the rain fed as there is no irrigations, and we go for the irrigated conditions where the saturation automatic when required, management depth 30 centimeter, flooding and the flooding conditions. So, you do the automatic, already have shown you in the previous weeks. If you go for the water management, so simulations, you can how you can change the on the simulation options, the water management as a saturations as a automatic irrigations, or if you want to go for irrigations, you can proper irrigations. Irrigation means different depth of irrigation maintained at different growth stages, specific growth stages, fixed irrigations, that can use the irrigation management file. Or in if you want to go for the automated irrigation, whenever that the soil moisture level goes below certain threshold level, then irrigation starts up to saturation. The irrigation is given to maintain the soil moisture up to saturation, and depth is maintained around 30 centimeter through flood irrigations. And here the irrigation 2 levels, and the planting time 25 July and 30 August. 25 July is around normal planting, we can say, for this location. 30 August is a delayed planting, very late planting. So, 2 planting date that indicate the crop experience different weathers if you change the planting dates. So, that takes into account the effect of weather variables. So, the year is 2014. So, do this exercise. So, write the grain yield for each treatment and discuss the results. This is for the exercise 2. So, where very specifically, as is now clearly explained here for this exercise, crop is your the rice crop, model is you are using definitely Ceres rice model, the year of experiment 2014, soil type you are using single soil, sandy loam soil, nitrogen level, the single level 200 kg per hectare of nitrogen, source is urea, nitrogen application schedule 25% nitrogen at 1 day after planting, 50% at 20 days after planting, and rest 25% at 40 days after planting. So, here treatment comes here. One is water management. One is now rain fed, let us say not irrigated. Then second one is the irrigated conditions, automatic irrigations when required, that is a management depth 30 centimeter. When soil moisture comes below the threshold level, irrigation starts, and the method the flooding irrigation in case of the rice crop we are giving. Planting date. So, the 2 planting dates to have the experience of the 2 weather, 2 planting date 25 July 2014 and 30 August 2014. So, this 2 planting date will give information about the weather variability. If there is a the crop is grown different planting dates, the crop is exposed to different weather, and the particularly crop phenophases also they are exposed to various weather parameters, and you can see if the planting date changes for the rain fed conditions and the irrigated conditions, for how the yield responds to the change in weather parameters, change in the water management, and change in the other of course is there. If you go for, if you plant different time, then crop does not only face the water management like a rain fed or the either the rain or the no rain, the crop also experience different other parameters like temperature, the different growth phases differ if you go for the different planting date, that also influence the final output. So, these are the information given. With this information, you need to create as a the treatment files. If you see the treatment file, so this is again you can go to the same, you can edit your the open DSAT as we explained earlier, same class, and this class same repetitions. Open the DSAT format, go to serials, Ceres rice, and open the experimental file, then edit that file as per the question, as per the objective of the exercise, that you can edit this experimental file. So, go to the soil type. Here we are putting the only one soil. The other class we had the 2 soil type we are putting, because of the soil was variable there. Treatment. So, we do not have a treatments on different soil type, since you are using one soil. So, create the field entry and choose the medium sandy loam soil. And here we have the planting dates. There you had one planting date. Here we have the 2 planting dates as your treatment. So, go to planting date and then management, the planting, set the planting dates as 25 July 2014 in for one treatment, and again to level 2, go to level 2 and set that planting date 30 August 2014. So, these are the treatments, one treatment planting date that you make a level 1 and level 2, and for level 1 planting date 25 July. Again the below portions in the model, you modify the dates, planting date and the emergence date and the number of seedlings at the time of permitters time planting as information was given, and the experimental file also you have explained the data inputs. Accordingly, you can fill the information for this planting dates. Similarly, for the 30 August 2014. Nitrogen we have only one label. So, they modify the fertilizer management, fertilizer N labels only 200 kg per hectare. So, that you can choose only label one label only. Water management. So, here you can go to the instead of going for the irrigation management, if you have the fixed amount of irrigations or different dates, you can go for the irrigation management. But for as for the current questions, we are going to solve the questions. We have mentioned that there is a either rainfed conditions or irrigation and irrigation is automated. So, that you can change in your this simulation options. Go to simulation options, create here two entries. One is for the rainfed condition label 1 and go for the label 2. Rainfed condition label 1. So, if you go to irrigation water management at the below portions, there you have to mention not irrigated, and go to label 2 here irrigated conditions, and if you go to that water management, there you give automatic irrigations. So, accordingly the simulation option file you have to change. Already you have explained you how to do in the data inputs, particularly experimental management data inputs. Hope you can follow this the previous exercise, previous lectures, where we have already explained detail about the crop management data inputs, and looking at that lectures, you can create here the treatments for this, let us say rain-fed conditions and irrigated conditions, making changes in the simulation options file. Then create the treatment. So, now you have the treatments means the two your the planting dates, one is 25 July 2014 and 30 August 2014, and you have the two water managements, that is rain-fed conditions and irrigated conditions. So, 2 into 2 you have the total 4 treatments. So, make these treatments in the desired treatments, then save the file, run simulations. So, these are the steps you need to do in the experimental management file. If you remember that one, it is well and good. You can also go back and refer to those lectures which are given for the experimental data inputs. So, following that lectures, you can make here the data inputs and create the treatments for this exercise, that is a two weather conditions, because of the two different planting times, let us say 25 July and 30 August in 2014, and two different water management conditions, one is the rain-fed conditions and irrigated conditions, which can be created in the simulation options. So, once you do this, then you can go and make the treatments. So, the treatment details, we have the 4 treatments, one is planting dates, 2 planting date 25 July 30 August, and 2 water management conditions, rain-fed and irrigated. So, 25 July rain-fed conditions, 30 August rain-fed conditions, 25 July irrigated conditions and 30 August irrigated conditions. So, these are the 4 treatment combinations where you want to go for simulations. So, that need to create the descriptions and treatment file. You can see this open this window, the treatment, where you can find the, you can make your the label 1, 2, 3, 4. You will have 4 treatments, give descriptions 25 July rain-fed conditions, 25 July irrigated conditions. Similarly, 30 August rain-fed conditions, 30 August irrigated conditions. So, these 4 description has to be given, where changes you will be making. I will show you one changes you will make here the planting time. The planting time, one is 25 July and 2 is 30 August. So, if you here see the cultivar remains same, cultivar you are not changing, field remains same, that is a sandy loam soil already there in the experimental management file, that remains same, that we are not changing. The initial conditions remain same, only here the planting time that is changing. 1 stands for the 25 July for the 25 July rain-fed and 25 July irrigated, that is for the 1, and 2 stands for 30 August. So, this is for the 2 and 2 for the 30 August rain-fed and 30 August irrigated. So, your change is here the planting time. Fertilizer, you are using the previous experiment, since the fertilizer has 200 kg nitrogen per hectare, and if see that fertilizer level 4 given that previous experiment. So, same experiment it is done here. So, we are choosing one fertilizer, that is for 200 kg per hectare. So, there is no change in fertilizer. And the other changes, you are going for the water management. So, if you see, this is about the planting time, and the second the changes you are making water management under this simulation control. So, if you see that you have identified label 1 rain fed, so not irrigated, and label 2 that we have given irrigated, and that is for the automated irrigations. So, for particular threshold levels, and when soil moisture goes below the threshold levels, and then we have to irrigation is given as we have explained in the data inputs as automated irrigations, and given up to the soil moisture reaches the 100% available. So, this is the irrigated automatic. So, this one stands for the rain fed conditions, 2 stands for the irrigated. So, accordingly you can see for this simulation control for the 25 July rain fed. So, 1 stands for the rain fed conditions, for 25 July irrigated, that 2 that is for the irrigated conditions. Similarly, for 30 August rain fed is put here 1, that is for the rain fed conditions, and the 30 August irrigated 2 for the irrigated conditions. So, this is very essential to create the treatment file. So, all your the exercise given to you, that if you see that exercise. So, for that exercise you have to create the treatment file. Treatment file, making treatment file is that depends upon the problem you have, the exercise you are going to do. So, based upon that exercise you have to find, you have to make that. So, what are the treatment has to be created. First created tables, these are treatments. So, accordingly suppose we have here the 2 planting date 25 July and 30 August, and the 2 water management rain fed and irrigated. So, first you have to create, you have to make sure yourself understanding, means these are the 4 treatment has to be created. To create those 4 treatments, you make changes in the experimental file. So, for the planting dates, make changes in the planting date files first. So, make the planting date 25 July and give the information for 25 July in the bottom portion of the model for label 1, and change the label 2 as a 30 August, and key accordingly. So, change the information bottom portion of the model for 30 August. So, that is for the planting time modification you do. Again you need for the modification in the water management simulation options to do label 1, that is say not irrigated as rain fed conditions. Accordingly make the information in the research file, and label 2 as irrigated automatic. So, once you do the changes in the experimental management file, then come to treatment details, create your treatments, 4 treatments as you are making the 25 July that is say rain fed conditions, or the 30 August 25 July are the irrigated conditions, 30 August rain fed conditions, or 30 August irrigated. So, those 4 treatments you can create in the treatment descriptions. Accordingly, the labels you can change as per the columns or different wherever changes planting time and the simulation options, there you can change as per your treatment specified in the treatment descriptions. Then you can go for simulation. For simulation, as the same steps you can follow as you did earlier. So, first you can go for the graphical output. For graphical output, I am showing here the as a topsoil total biomass. You see here this green color that shows the biomass that all the either the 25 July planting or the 30 August planting, whether it is irrigated or rain fed, the biomass remains same up to certain date, around 60 days after planting. After that, so there is a significant difference in the biomass for the different planting date. You see the 30, this green color shows 30 August rain fed. If 30 August planting rain fed, 60 days after planting the biomass remains same, there is no change in biomass. Whereas, for the other dates let us say 25 July, that is say irrigated or rain fed, either the topsoil, the 25 July rain fed, 25 July irrigated and 30 August irrigated, even 30 August irrigated, that was an increasing biomass. So, this is what say the late planting, the late planting rain fed conditions. So, 30 August late planting rain fed conditions, the biomass does not increase after certain dates, 60 days after planting. If you see 60 days after planting, the crop has come to flowering stage, and probably you have planting in August 30 and the 60 days it comes around 2 months, September towards October, and there during that periods there is probably no rainfall. So, there is no enhancement in the biomass, whereas that is other two. If you irrigate 30 August for the irrigated conditions, for the biomass is increasing, the crop gets sufficient amount of water, there is a significant increase biomass 30 August irrigated, and that shows the highest biomass among all the treatments. The reason can be 30 August if there is a if you go on irrigations, that gives a higher biomass, because the probably the crop gets optimum other parameters like temperature, you can say humidity or solar radiation, that is conducive for the crop growth at 30 August planting. If you have the sufficient irrigation for the crop, that gives a better biomass. And if you go for the grains weight also, grain weight you can see here the similar response. You see the 30 August planting as a rain fed conditions, the green color, 30 August planting rain fed, that shows significantly lower grain weight, because no grain filling, that is in the so the grain filling stops here because of the stress, lot of water stress here, but where the maximum yield you get the grain weight 30 August irrigated condition, that gives the highest yield, because of probably other parameters are favorables and the crop is getting sufficient amount of water, the crop does not suffer from water stress. So, yield is much higher here. And if you see the overview output file here for all this model, see the crop is rice. So, I have already explained rice. Planting date, starting date we have given July 15. So, planting date here the 25 July and 2014. So, other informations are given here, and this is rain fed conditions. So, not irrigated, and the nutrient application is same 200 kg per hectare in 3 applications given. So, initial days and the and then different date 3 applications. This is the residue manure not given, but this is the residue manure as per the initial condition is given. Then environmental optimum, simulation optimum as you are specified in the model. So, this gives the input informations at the desired output what you want, the simulation output, management outputs, or the input what you have put here, that you can see here. We have shown only for the one treatment 1, where the rain fed July 15 and this is not irrigated, planting on July 25 planting, and this is not irrigated, so rain fed conditions here. And here see the here the crop biomass, and here you can see there is a different days simulation for July 25. So, different days of simulations, different days what is the biomass, and since I can show you here there is no water stress here, since you are planting on July 25 you will not find any stress of the water here. But if you see the August 30 planting, I have not shown here the August 30 planting will show definitely water stress for this in case of not irrigated conditions. It is not irrigated, but there is no sign of the water stress here. So, this is you can see, and here also you can see the leaf area index also, that is increasing up to 5.51. The earlier I have shown you leaf area index goes only 1.5. So, 0 kg nitrogen. Since you have the stress of deficiency of nitrogen, so the crop there is also you can see there is no N stress, not so much N stress, the crop does not suffer in N stress, it gets sufficient amount of nutrient, the leaf area index also increases up to, he had gone to up to 5.55 the maximum leaf area index, then upwards towards maturity the leaf area index is decreasing. But similarly, there is increase in biomass this, and this is the final output. You can see the model simulated. the panicle initiation day around 31 days after planting. Anthesis the flowering days, that is 63 days after planting. The crop matures at 91 days after planting, and the yield at harvest maturity 7253 kg per hectare. So, unit weight, that is the single grain weight 0.023 gram, and the numbers of grains at maturity numbers per meter square 31.533, and number of panicles per meter square 1022, and the tops weight at flowering, and the tops N at anthesis how much nitrogen, tops weight at maturity, and the byproduct harvest the straw weight at maturity 6320 kg per hectare, harvest index 0.534, leaf number per stem at maturity, then grain N at maturity, grain nitrogen uptake, tops nitrogen, total nitrogen uptake maturity 163, stem nitrogen, that is 60, grain N content 1.42. So, these are the informations given for the you can use this information for your particular simulations, this output. So, if you see the yield value here, so this is the data for the yield data. So, 25 July and the 30 August planting, rain fed conditions and irrigated conditions. If you see 25 July, the rain fed and irrigated, you do not find any difference in the yield. So, same yield, if you go for the 25 July planting, so irrigation is not essential. The crop gets sufficient amount of rainfall to have the maximum productions. So, there is no change in yield with applying irrigations. So, whereas in case of 30 August planting, if you see the under the rain fed condition, yield is 1101 kg per hectare, whereas under irrigated is 7272 kg per hectare. The maximum yield you are getting under the irrigation condition in 30 August planting, because of the the under rain fed conditions, the crop late planting, with late planting rain fed condition, there is a severe reduction in the crop yield. That gives understanding. If you go for the reality of the field experiment, if you go for delay planting and there is no life saving irrigation for the crop will suffer, you will not get the production. There is a huge loss, economic loss to the farmers for delay planting, particularly for the monsoon agriculture, when you depend upon the rainfall. So, when there is no irrigation facility, you are growing rice under rain fed conditions. Timely planting is very essential to maximize productions. For any reason, if farmers goes for the delay planting, there will be severe reduction in the crop yield. The farmer may not get any return, that will huge economic loss. So, timely planting is highly essential, that is reflected from this from the use of the crop model. If you have the irrigation facility, then the delay planting 30 August, that can give a good yield. But again if you have irrigation facility, the planting if you go 30 August, even though you get a good yield, irrigated conditions, the next crop the rabi crops you have to sow on time. If you go on delay planting, the sowing of the rabi crop, you are going by the cropping system, the two crops from sequence, the sowing of rabi crops will be affected. So, looking at the cropping system management, it is very essential to choose the planting time. So, however, though irrigated conditions give a higher yield, but the planting on time 25 July is recommended, because to accommodate a second crop in the growing seasons and optimum time. So, this gives information. So, for the under the rain fed or irrigated, so optimum planting time around 25 July, that as per the model simulations in reality field experiment also, that applicables planting in optimum time, that give the maximum productions, and also that helps for the synchronization of the sowing planting of the crops in sequence to that crops will following this crop in the cropping systems management. So, using this model we can give a proper information about the management decisions for the planting time and input management for maximizing the crop productions. With this I thank you all.